It is important to be honest when reporting a measurement so that the measurement does not appear to be more accurate than the equipment. Therefore, scientists use the concept of significant figures to communicate the accuracy in the measurement or a calculated value. So what does it mean to be significant? It means measurements have meaning. They are more than just numbers. Measurements are obtained by comparing an object to a standardized unit on a scale. We show significance by the number of digits present in the measurement. Therefore, significant figures includes all the digits that are known, plus a last digit that is estimated. The measurement that we record communicates to others about the accuracy of the measurement instrument. The better the marks on the scale, the closer the measurement comes to the true answer. Let's examine a few scales. But first, remember, scientists always understand that the last significant figure on the right side of the measurement is the estimated digit. The measurement tools that we will examine measure distance in micrometers. The first scale has calibrated lines to represent the ones place. Therefore, the length of the green line is 4.5 micrometers. This measurement has two significant figures. The second scale has calibrated lines to represent the ones and tens place. The length of the green line is recorded as 4.55 micrometers. The measurement has three significant figures. Now you try the third scale. Record the length of the black line and state the number of significant figures in the measurement. Now let's check your answer. The scale has calibrated lines to represent the hundredths place, tens place, ones place, and tenth place. Therefore, the estimated digit is in the hundredths place. The length of the black line should have been recorded as 142.13 micrometers. This measurement has 5 sig figs. What if the measurement tool is not available for us to look at? How do we know how accurate the scale on the measurement tool really is? Remember, all scientists understand that the last significant figure on the right side of the measurement is estimated. So if we know how many significant figures are in the measurement, then we can have an understanding about the accuracy of the measurement tool itself. Therefore, there are several rules for counting the number of significant figures in a measurement when a measurement tool is not available. Rule number 1. All non-zero digits are significant. There are 4 measurements below. Record the number of significant digits in each measurement. You will have approximately 10 seconds to do this. .15 centimeters has 4 significant figures. 5.6 feet has 2 significant figures. 65.6 pounds has 3 significant figures. 122.55 meters has 5 significant figures. Let's take a look at these two scales. On the top scale, you have markings for the 100th place, but you're estimating the tens place. So the measurement could be read as 140 centimeters. On the bottom scale, you have markings for the 100th place, and you have markings for the tens place, but no markings for the ones place. So you are estimating the ones place, and it appears that the line is directly on 140 centimeters. So if we don't have the scales in front of us, how do we know the difference between 140, in which you are estimating the tens place, and 140 centimeters that you are estimating the ones place? When a measurement tool is not given, there are 3 simple rules to determine whether a zero is a significant figure or not. Rule number 2 states, any zero between non-zero digits are significant figures. Given our 4 measurements below, record the number of significant figures in each. You will have 10 seconds to do this. "50.8 millimeters has 3 sig figs. 2001 miles has 4 sig figs. .702 pounds has 3 sig figs. 400,000 5 meters has 6 sig figs. All of these measurements contain zeros between non-zero digits. Therefore, the zeros are considered to be significant figures." Rule number 3. All zeros to the left of non-zero digits are not significant figures. Below, you'll see 4 measurements. Record the number of significant figures in each measurement. You'll have 10 seconds to do this. .008 millimeters has 1 sig fig. 0.0156 grams has 3 sig figs. 0.0042 seconds has 2 sig figs. 0.000262 milliliters has 3 sig figs. All the measurements contain zeros to the left of the non-zero digit. Those zeros are not considered to be significant figures. Rule number 4. Zeros to the right of all non-zero digits are only significant figures if a decimal point is present. Below, you see 3 measurements. Record the number of significant figures in each measurement. .00 inches has 4 significant figures. 0.0200 years has 3 sig figs. 10 gallons has 1 sig fig. Zeros to the right of non-zero digits are only significant if the decimal point is present in the measurement. Rule number 5. Counting numbers and numerical definitions are said to have an infinite number of significant figures. Some examples are as follows: 3 apples, 8 molecules, 1 inch equals 2.54 centimeters. An alternative method for counting the number of significant figures in a measurement is called the Atlantic-Pacific method. Instead of memorizing many rules, this method relies on only 2 rules that depend on the decimal point being present or absent. The first rule is, if the decimal point is present, count all digits from the Pacific side of the measurement, starting with the first non-zero digit. Let's look at a few examples. Starting with our first example, 40,603.23 square feet. Starting on the left side of the measurement, because the decimal is present in the measurement, we start with the first non-zero digit on the left, which is 4. Starting with the 4, moving from left to right, we count all the digits, including all zeros, and we see that we have 7 sig figs. In the second example, 0.01580 milliliters, we're going to start on the Pacific side of the measurement because the decimal point is present in the measurement. Starting with the first non-zero digit, which is 1, we're going to go left to right, counting all the digits from that number 1. And we count, we see we have 4 sig figs. The second rule is, if the decimal point is absent, count all the digits from the Atlantic side of the measurement, starting with the first non-zero digit. Now let's look at some examples for the Atlantic rule, starting with 40,600 square feet. Since the decimal point is not actually present in the number, we're going to start with the Atlantic side of the measurement, which is the right side. We're going to move right to left, and we're going to hit the first non-zero digit, which is 6, and then continue counting all digits from right to left, including all zeros. And you'll see that you have 3 sig figs in 40,600 square feet. In the second example, 1,000 milliliters, the decimal point is absent, so we'll start on the Atlantic side of the measurement. Moving right to left, we're going to look for the first non-zero digit, and we're going to count all the digits right to left from that non-zero digit. Starting with 1, there's 1 significant figure in 1,000 milliliters.